Okay, hello everyone. My name is Giovanna Angelica Vasquez, and my work is synthesis and characterization of a new organic semiconductor, 1-parafullerene phenyl 2,5-diphenylpyrrole by formation of diazonium salts. Okay, in this work, we have prepared new derivatives of 2,5 aromatic disubstituted pyrrole functionalized with fullerene by applying the diazonium salt procedure. Subsequently, we implement chemical and structural characterization of this pyrrole derivative. Finally, their optoelectronic nature was evaluated, applying a thin film analysis. DFT calculations were undertaken to establish the source of the electronic behavior and then compared with experimental results. This new compound has a semiconductor behavior. Okay, in the introduction, the different materials according to their electrical properties are classified into 3 groups: metals, insulators, and semiconductors. Especially organic semiconductors have gained great interest in recent years thanks to their important properties and with which they have been applied to different fields such as flexible electronics. In this case, these important properties are low cost, low weight, simple processes, large areas, and flexibility. Okay, in the methodology, to carry out the synthesis of new compound is divided into 3 different stages. The synthesis of the precursors and the reaction in which the diazonium salts are involved to functionalize the pyrrole with fullerene. Okay, finally, we obtain a dark brown powder, and the yield of this compound was the 57.89%. Subsequently, the product obtained was characterized by infrared and nuclear magnetic resonance to obtain information on its structure. In the infrared spectra, the absorption bands corresponding to the amino group on 34, 13, and 33, 31 inverse centimeters disappear. And the pyrrole characteristic band of 56 reverse centimeters is visible, as well as those at 14, 27, and 524 inverse centimeters, which are attribute the CC and WCC bonds on fullerene. The NMR study was carried out on solid state because the strong insolubility of fullerene derivative. The signals corresponding to pyrrole fragment and fullerene were identified. Thereafter, the band gap energy value of the compound was determined from data obtained theoretically and experimentally. The value obtained by DFT was 1.82 electron volts, while the value of the band and energy band gap obtained by the Kubelka-Monk method was 1.75 electron volts, so there is good correlation between both values. Okay, to determine its possible function in optoelectronic devices, an analysis of these properties must be carried out on thin films of this material. To determine the method of making the film, it was necessary to carry out a solubility study and determine the boiling point of the compound, which was 205.23 centigrade grades. The low pressure sublimation technique was chosen. This technique was chosen because of the high quality uniformity, the vaporization under low pressure, bearing in mind its possible application for optoelectronic devices. An FTR analysis was carried out after the deposition procedure to ensure the preservation of the integrity of the compound, which was confirmed. The X-ray diffractogram corresponding to the thin film deposit on a substrate of monocrystalline silicon. The fact that diffraction peaks are well defined is very significant, and this may indicate that the sample is polycrystalline, meaning that electronic transitions will be well defined. The signals correspond to a cubic face centered on the faces of the fullerene. The study of morphology and uniformity was achieved using the same technique. The thin film was deposited on silicon wafers. The uniformity of the surface with homogeneous distribution over the base. There are no holes or particle clusters. This morphology is the result of the film growing process, which initially reacts to high temperatures, with that subsequent gradual lowering of these values, favoring the formation of grains on the surface. These attributes strongly suggest good electronic characteristics. Finally, the film was evaluated in terms of its electrical behavior. To carry out measurements of electrical current voltage, IV graph, and the film was deposited on glass substrate using ito and silver as electrodes. According to the IV graph, the film exhibits symmetrical behavior because of the ambipolarity. This ohmic behavior and the value of the band gap are an indication of the semiconductor character of this compound, demonstrating the possibility of using it in optoelectronic devices. Okay, well, in the conclusions, the synthesis of the Jasonian salts method has been applied successfully to functionalize fullerene molecule with 2,5-disubstitute pyrrole. The reaction with fullerene makes it possible to create a fullerene species with a CC bond, which using SM shows a globular conformation characteristic of fullerene derivatives. The Kubel-Kamong analysis and DFT study showed that the new compound manifests semiconductor behavior. And finally, based on the results obtained from the IV analysis, it appears that this semiconductor can be used as a resistor. Thank you very much.